This is a video on adding and subtracting rational expressions. First, let's go through the steps. So to add or subtract rational expressions, the first thing you want to do is determine the LCD for all fractions that appear in the expression. So when I'm talking about the LCD, I'm talking about the least common denominator for all fractions that appear. Step 2, and it's important you realize this, is a rewrite step. You're going to rewrite each fraction using the LCD as the new denominator. So each fraction has to have the LCD as the denominator before you're allowed to add or subtract them. Once you've rewritten each fraction, now you want to add or subtract as normal for fractions. This means you add or subtract through the numerators, and you keep the denominator as the LCD. And then your last step is to simplify if possible. So if you can reduce at the end, you should. Let's take a look at a few examples. So for our first example, we want to subtract 4 over x squared minus 5 over 7x. So we're subtracting two fractions here. And whenever you add or subtract fractions, the first thing you should look for is to see if you have a common denominator. Here we have x squared and 7x, so they're not the same denominator. So we don't have a common denominator. We want to find the LCD. We want to find the least common denominator. And for numbers, for the coefficients here, we got 7 and 1. There's really a 1 in front of that x squared. So the smallest number that 1 and 7 can both go into evenly would be 7. And then for variables, I have an x squared and an x. And basically you want, the highest power of x that you see here, because you want the one that both of these variables can go into evenly. So that would be x to the second power. So our LCD is 7x squared. And this is the rewrite step. I'm doing this over here on the side. Sometimes people do it inside the problem, but I like to do it on the side just so you can kind of see where everything's coming from. So I have to rewrite each fraction. I have to rewrite 4x squared, being the first fraction here, or 4 over x squared I should say, being the first fraction. It should be equal to something. I don't know what's up top yet, but it has to be over whatever the LCD is. So it has to be over 7x squared. And basically you want to ask yourself, okay, x squared times what gave me a 7x squared? Well, you really multiplied by a 7 down here. So whatever you did in the denominator, you got to do up top in the numerator. So 4 times 7 will give you 28. So we're going to rewrite the 4 over x squared as a 28 over 7x squared. So I'm just replacing that first fraction with 28 over 7x squared. This is a minus sign, so it's going to stay minus. We're still subtracting. And then we're going to rewrite our second fraction. So we're going to rewrite the 5 over 7x is equal to something. I don't know what the numerator is yet, but it has to be over the LCD. It has to be over 7x squared. Then you ask yourself, 7x times what got me to a 7x squared? Well, 7x times an x will get you 7x squared. Whatever you do to the denominator, you also do to the numerator, so 5 times x just makes this 5x. So we're replacing the second fraction with 5x over 7x squared. Now we add or subtract as normal. So this is all kind of over on the side right now. Now we add or subtract as normal. So we got 28 minus 5x, and they're not like terms, so you can't combine them. We're just going to write it as 28 minus 5x. Alright, and that's going to be over the LCD, which was 7x squared. Now if you could reduce here, you would by factoring out of the numerator, but there's nothing to factor out of the numerator here, and there's nothing that can cancel with the 7x squared. You can't cancel the 28 and the 7 because it's now connected by that negative sign to the 5x. Alright, so you can't cancel any more here, you have to leave it like this. Alright, and that's your final answer. Let's take a look at another one. So we want to add 5 over 8x squared y to the 5th plus 7y over 12x fourth y to the 3rd. And remember, the first thing you're looking for when you're adding or subtracting is an LCD. And in this case, we don't have a common denominator to begin with, so we got to find one. And we want to look at the coefficients and then the same variables with the same variables. So 8 and 12, the smallest number they can both go into evenly is 24. And then we have x squared and x to the 4th. And the smallest thing that they can both go into evenly would be x to the 4th power. Alright, so you always want the largest power of the variable that you see down here. So x squared and x to the 4th, we want x to the 4th. And then between y to the 5th and y to the 3rd, we need y to the 5th power. That's the smallest thing they can both go into evenly. It's the largest power you see. And now we're going to do our rewrite step. We want to rewrite each fraction we have here using the denominator as 24x to the 4th y to the 5th. So we have 5 over 8x squared y to the 5th is equal to something. I don't know what it is up top yet, but it has to be over 24 x to the 4 y to the 5. And you just want to ask yourself, what did I multiply 8x squared y to the 5th by to get to a 24x to the 4th y to the 5th? And you should do this in steps. 8 times what gave you 24? Well, that would be 3. X squared times what gave you x to the 4th? Well, that's times another x squared. And then y to the 5th stayed y to the 5th. It's really multiplying it by 1, but you don't want to write that in there. If the thing doesn't change, right, the variable doesn't change, y to the 5th stays y to the 5th, then we don't need to multiply by anything. So we multiply the denominator by 3x squared. You also have to do it to the numerator. So we have 5 times 3x squared gives us a 15x squared. And that's what we're going to replace our first fraction with. It's going to be 15x squared over 24x to the 4 y to the 5. Alright, and this is going to be plus, because we have a plus sign here. And now we're going to rewrite our second fraction. We have 7y over 12x to the 4 y to the 3rd. This should be equal to something. We don't know what it is yet, but it has to be over our LCD, which is 24x to the 4th y to the 5th. And now we're doing the same thing as before. Right? 12 times what gave me 24 down here? Well, that'd be times 2. X to the 4th stayed x to the 4th, so we don't need any x's. And then y to the 3rd times what gave me y to the 5th? Well, it's y to the 2nd power. So we multiply the denominator by 2y to the 2nd power. You also have to do it to the numerator. So 7 times 2 will give us 14. Y times y gives us y to the 3rd. So we're replacing the second fraction with 14 y to the 3rd over 24 x to the 4th y to the 5th. Alright, and now remember, you add or subtract the same way you normally would for fractions, which means straight through the numerator. So we have 15x squared plus 14y to the 3rd. They are not like terms, so you can't combine them. And it's all over the denominator of 24x to the 4th y to the 5th. Now, you should always check to see if you can factor something out of the numerator, because you can, it may cancel with the denominator. In this case, you can't factor out of the numerator, so that's all we can do. We can't do anything else here. That's our final answer. Alright, if you had not picked the correct LCD, if you picked something larger than the lowest, you would have to reduce at this last step. Alright, here's a video homework example for you to try on your own.